Hey there, Franklin. Here's what I want to do. So on the back side of your paper, you should have something that looks very similar to this. And what I want to do is I want to show you mathematically, or for instance, visually, that a straight line going up on an angle will show you that an object is moving at a constant speed. That a flat horizontal line on a distance versus time graph will show us that an object is not moving, and that a line going down on the angle means that the object is going back towards the starting point. So flip it over, and here's what I'd like you to do. All right, so let's talk about how a straight line, excuse me, I got a frog in my throat, um, proves that an object is traveling at a consistent speed. So the first thing I want to do is I want to label these real quick. So this is d for distance, because remember the y-axis shows this distance. And for right now, let's just put it in miles. We're going to do miles per hour. I know that that's not metric, but just to keep things easy for today. Then we're going to put our time in hours. Okay. And then what I want you to do is we're going to label this real quick. So this is going to be 0 miles that we traveled. It's going to be 1 mile traveled, 2, 3, 4, and 5. So each of these numbers represents how many miles away we are from the original starting point. So if we're 0 miles away, then we're at the starting point. Now on our x-axis, this is going to represent the number of hours. So this is 1, 2, 3, 4, 5. So along the x-axis, this will tell us how many hours it took to get to each one of these spots. Okay. So let's plot a few points real quick. So let's go 1 here at 1, 1, another one at 2, 2, see 2, 2, another one at 3, 3, another one at 4, 4, and another one at 5, 5. Then what I want you to do is take a ruler. I don't have a fancy ruler. And we're going to draw a straight line. And the straight line is cut through the center of each one of these boxes. So in order to do that, you need to make sure that you actually line up the ruler so that it goes past the center of each one of these dots. And let me try real quick and see if I can do it pretty accurately. Yep, just like that. All right. Now, let me show you how this proves that the object is moving at a constant speed. So remember speed, and I want you to write this, is distance divided by. So in order to find the speed of something, take the distance that it's traveled divided by how long it took to get to that specific distance. So for instance here, if we look at 1, 1, the object traveled 1 mile in 1 hour. Well, that's pretty slow. Yeah. Well, if we take 1 divided by 1, we get 1. We get 1 mile per hour. And I just need to write that off the side real quick, so I'm going to show you something. Let's try another one real quick. So the object is now 2 miles away from the starting point at 2 hours. So 2 divided by 2 is 1 mile per hour. And we're calculating speed, distance divided by time. Well, let's do this one more time. So 3 miles away from our starting point. It took us 3 hours to do that. 3 divided by 3 is 1, so it's 1 mile per hour. And if I just keep going, 4 divided by 4 is 1, 5 divided by 5 is 1. So this proves mathematically right here that a line that is straight and going up the upward angle means the object is always traveling at a consistent speed or the same speed. And that's really what I want you to write right here. Is it constant speed? Constant speed. Okay? Now, the next thing I want to show you is this. I want to show you that a horizontal line means that the object is not moving. And the reason why I left these blanks is because I wanted you to get to practice actually labeling distance versus time graph. So same thing, distance in miles, time is in hours. We're going to do the same thing as up here. We're just going to label these numbers. So this is 0, 1, 2, 3, 4, and 5. I'm going to put that out there so you can see it a little better. Sorry, that's not an 11, that's a 1. Same thing here. 1, 2, 3, 4, and 5. Now, I could show you the horizontal line starting at 0, but that's going to be a little difficult since I already have a marker here. So let's just suppose real quick, we're going to start with my object 3 miles away. Okay. So it's going to start 3 miles away. And in 1 hour, it is still 3 miles away. And at 2 hours, it is still 3 miles away. And so on and so forth. So let's draw our 5 dots all the way out, or technically 6. When you got that, don't just go straight across. Please use the graphing technique, which is to always use a ruler no matter what. Okay. And I'm going to check this, and if these are sloppy, you're going to redo them. So please make sure that you do this correctly. Well, look at this real quick. If after 1 hour it's still 3 miles away, and after 2 hours it's still 3 miles away, notice it's not gotten any farther away from the original point, the home base, so to speak, and it's not gotten any closer. If it's still 3 miles away, no matter what time it is or how much time has passed, then you know that the object is not moving. Okay, and if this does not make sense, I need you to immediately pause the video and come up and ask me to explain this a different way to you. The same with this one. All right. So horizontal line proves that an object is not moving. Last one, a line going down on an angle. Well, you know what we're going to do here, so let's just do it real quick. Distance is in miles. Time is in hours. I should have wrote that a little lower. Sorry. 0, 1, 2, 3, 4, 5 miles away from the starting point, and 1 hour it took 2, 3, 4, 5. Now, an object going down, so in the opposite direction of this, shows that it's returning to its original point, or heading towards its original point. So let's start here. Let's say we start at 5 miles away from our original spot at 0 hours, okay? And then in 1 hour, it's 4 miles away. In 2 hours, it's 3 miles away. So in 2 hours, it's 3 miles away. In 3 hours, it is 2 miles away. 4 hours, it is 1 mile away. And at 5 hours, it is finally back at its spot. Now, if you're like, well, no, it's not because home is here. No, home actually represents, in this case, this entire line. Okay. So if at any point one of these dots hits that, you know that it's back home. It's reached the bottom of the y-axis. Same thing. Here's the graphing technique. Use a ruler. Okay, straight edge. Connect the dots best as possible. Okay, like that. So this proves that the object is actually returning to its original point because its original point is down here and it's gradually moving closer. Okay. All right, and we're going to label this as going back towards its starting point. Its starting point. All right. Now, in just a second, you're going to fill this in on your own, but you need a little more information to do that. So we're actually going to create a story here real quick. So here's what I want you to do. I want you to plot some points for me real quick. Well, first of all, let's do this. Let's label our y-axis distance, our x-axis in time. Oops. sorry, should be time in hours. My bad. And we're gonna label it again. So 0, 1, 2, 3, 4, 5. Now here I've given you a longer one, and I need you to go all the way to 12 for me real quick. So 1, 2, 3. This makes sense in just a second. 4, 5, 6, 7, 8, 9, 10, 11, 12. So our story, quote unquote, that we're going to draw graphically, it's going to take 12 hours to do it. Well, we're not taking 12 hours. The activity will. Let's plot. Ready? So we're going to go 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 and stop there. Then I want to go over 4 more dots. So we're going to go 1, 2, 3, 4. So now you're at 8, comma 4. 8 on the x-axis, 4 on the y-axis. And then we're going to go back down the angle like this. So this is 9, 3, 10, 2, 11, 1, and then 12, 0. Now I want you to connect these so it looks like you have a little ramp. Like this. Even though this is a straight line and you could probably trace over it, I would still use your ruler because that's using good graphing technique. And that's what I was told to tell you when I learned this in college. I always tell them to use a straight ruler. It doesn't matter how straight they can draw their lines. So I'm telling you that. All right. So in this story, you can see that an object starts at its home position. And let's just label this home real quick. And by home, I just mean its starting position. Okay. And you're going to see that it travels away, yes, for 4 hours. Then it doesn't move, and then it returns back home. So essentially, what I've done is I've taken each one of these pieces and I've connected them together. Yeah. Constant speed. So this is moving at a constant speed away from home. Yeah. Then it doesn't move, and then it returns home at a constant speed as well. Okay. Now, if you just listen to what I said carefully, this next part should make sense. I want you to put a letter A right here. A represents what's happening on this line right here. B represents what's happening along this line right here. And C represents what's happening along this line right here. Your assignment now is this. When you come up to me to show me this whole thing, this needs to be filled out. And what I want to know is I want to know what's happening along line A. What is the object doing? Yeah. Use your notes up here. Okay. I want to know what is the object doing along line B. And then I want to know what is the line, or excuse me, what is the object doing along line C. It doesn't have to be a complete sentence. You can quickly jot some notes down, but use your notes to help you do that. Okay. And then when you're done, like I said, come up and show me, and I'm going to check this to see if you learned anything. Thanks.